Hello everybody and welcome back to Kerbal Space Program, where we are kind of struggling to get this thing into orbit. We don't really have the thrust to weight that we need from these engines to get this thing there, but I think that we're overkill enough on our landing stage that we can have this be a combination maneuver and landing stage, because really we only need, what, like 800 DV to get to the moon, 200 to circularize, another maybe 1,000 tops to land and take off, and then another 400 to get back. I think we have enough. So, let's see if we have the thrust to weight. That's the real question here. This will be another substantial thrust to weight bump here. And assuming that we have the thrust to weight, that's the only issue other than a potential DV issue. If we have a DV issue, we can do a flyby and grab some science that way, or we could grab some land science and get the engines that we need to really pull this off. But let's give this a go. Our thrust to weight here is 1.52 instead of the previous 1.4, so this should be much, much, much better. Just starting that gravity turn pretty early here because I want to make a pretty efficient ascent profile, if we can manage it. Getting some pretty serious aerodynamic forces fighting us, but it should be completely fine. Apoapsis of almost 10 kilometers. Ideally, I'd like to be at 45 degrees by the time we detach these tanks. I don't know if that's feasible. We've got a ways to go yet. I mean, I could force it, but I don't really want to do that. Yeah, aerodynamic forces are fighting us quite a lot, so it's going to be right here. There we go. And we're just going to continue pitching over. Our inclination is going to be a little bit off because of our heading there. I'm just making some slight corrections for that without looking at the actual amount that our inclination is off. We do need to be basically at the horizon right now. And look at this speed. This is so much better. How's our inclination looking? Okay. Should be almost done. Yeah, we're going the other way a little bit now. No, come on. Aerodynamic forces, please let me go back up. Okay, there we go. The SAS bugged out a little bit there. But that's fine. Okay. So we have another roughly 500 DV out of this, which should be sufficient to get us there. Well, not to orbit, but it should be sufficient to get us to where we need to be. Although our time to apoapsis is currently decreasing. So it'd be so much better if this center stage was like a skipper or something like that. Like we could have a super heavy lift rocket if that was the case. But we're not there yet. There we go. Just had to do a quick fix there. This is slightly awkward. We're going to go ahead and decouple that manually. Had a slight staging issue there that I didn't notice previously. And this thrust to weight is quite low, but it'll start going up over time. So we're almost at the apoapsis right now. Our apoapsis is a little bit lower than we were aiming at before, because we made a bit more efficient of a turn, DV-wise. And we're starting to go back down now. I'm just going to lock it to prograde currently. Yeah, we still have a pretty massive thrust-to-weight disparity here. Which is definitely unfortunate. We're getting closer. There's no doubt about that. I wonder if maybe we can get the science that we need out of this flight for a skipper. That'd be nice. That said, we're getting close to orbital velocity. I would like to get us a little altitude again. Like be burning this way to fight gravity some. That'd be ideal. Or we could just push through the atmosphere and fix it when we get up around the other side. We would just need to get our periapsis high enough, which would mean just going for as much orbital velocity as possible. That might be our best play at this point. I mean, we're very close, but we've burned a lot of fuel out of our landing stage. I think we have enough if we were in orbit right now. We're really close to orbit, though. We just need another, what, like 200 DV? We're dropping fast. Maybe we should just aim higher. We could do that. Periapsis is coming up quickly, but is it quickly enough? I kinda doubt it. This is gonna be spicy. Our apoapsis is up there. But yeah, this is 100% a thrust-to-weight problem. I don't think we can get the speed that we need at this juncture. I mean, at this point, we should be burning, like, straight up, but we're gonna start tumbling like that. Yeah. I mean, we're pretty low in the atmosphere at this point, and it's just because of the thrust-to-weight. So we're just gonna try to bring this back as best we can. We're gonna deploy our air brakes and see if we can just get to retrograde here and burn off as much speed as we can. And we're going to try to come back and see if we can maybe get some ocean science, maybe some flight science to get what we need tech-wise, because this just isn't working. Are those the air brakes that are overheating right now? I think so, but they're going to be okay, it looks like. So we're just going to recover this as much as we possibly can, which I think is going to be a pretty hefty amount, actually. Drogue chutes deploy as soon as they can. Those are deployed, right? They don't seem to be. There they go. Main chute out. We're going to cut our burn. Physics warp towards the ground. SAS can go off. We can't really get science here. Although we could get a mystery goo observation and a material study, I guess. That would work. Drogue chutes will deploy momentarily. There they go. And the main chute will follow shortly thereafter. Okay, 16 meters per second. That's not too bad, really. So we're going to begin burning to try to rescue as much of this stage as possible, and we're just going to attempt to get some science out of this. Okay, so basically exactly the same thing happened. Fair enough. So we're going to go ahead and have Bob get out, grab a surface sample, which will be worth some amount of science, and we'll recover this. I should have collected the experiments, but I thought that we'd survive that splashdown for some reason. When we're coming back properly, by the way, we're not going to have those 4 side tanks or that engine, so we should be more than fine. It's just that we're aborting it early on. 82.6%, or 82.6 science. For this, we need 90 science. That's like 8 more science. Let's hop into the VAB and grab a little extra science. So we're going to save this. This is going to... I mean, we're probably going to end up putting the interstage back after this. We're going to create a new vehicle here. And we do have wheels. That's great. I think we'll need to use a Mark 1 command pod. This is going to be really awkward and dumb looking. Don't worry about it. It'll be fine. So we're just going to put some solar panels on here, like so, although I don't want them obstructing the hatch. So like so. And then we are going to just put some landing gears on here. Not necessarily all facing different ways like that. That would not go well. We could... How do I want to do this, then? We're going to have to, I think, do it something like this. Let's see, which way do I want to rotate it? I want to rotate it like that. Like that. And like that. It's going to be really awkward. Jeb is going to be in that. And let's see if we can roll around and gather just a tiny bit of science to get this thing off the ground. I was not expecting to have these thrust to weight issues. We can grab this surface sample right off the bat, and that would be perfect. We're going to grab that. That's not all we can grab, of course. I did not think of this. We're going to need the SAS off. Okay, there we go. So control wheels are going to be on SAS only, or rather the reaction wheels are. And let's see, some of these are, I think, going the wrong direction, even though they're all facing the same way. You can see this one is turning opposite, but that's actually fine. Do these not have motors? Oh, they don't have motors. Okay, so we're going to have to recover this. I'm just an abject failure, I guess. We'll just have to recover that. And we'll make a couple of tweaks. The first one, and yeah, we're up to 84 science. The first one that we're going to do is we are going to turn off the reaction wheel, or rather put it on SAS only right here. So the reaction wheel is on SAS only, and now we need one of these with an actual motor. Which... I think none of these have. Okay. Jeb, I guess you're walking. So we're going to have an experiment storage module here. Like so. And we're going to have Jeb get out and walk his way around a little bit. That's okay. We only really need to get to like one biome, right? So we'll just hop out here. Grab the surface sample. Hop in. Collect that. And then hop back out. And Jeb, you are very slow. Let's try running. We just need to get off of the landing pad. Go, Jeb, go! Surely it would be easier to do this not in a spacesuit. You'd think. I don't think that Jeb has the power to fly here, does he? Absolutely not. I did not think so. So RCS off, and we're just going to run down here. And is it over here that we get off the launch pad, or over here? I don't know, but I think we can physics warp this. Absolutely, we can. Excellent. So we're going to run over this way. We may have to get to one of these structures. I'm just looking for a different biome. Oh. There was one here. Yes. Crawler way. EVA report. Surface sample. Got him. Okay, now we got to get back. Actually, we could just recover. So we recover that. And then we'll also recover the ship that is there. I use the term ship very loosely. And that gives us the science that we need. So we'll recover that. Excellent. And now we can grab heavy rocketry, which gives us access to the Skipper liquid fuel engine. And then we can hop in here, and we're going to need... The Skipper is going to look weird, right? It's going to be the wrong size for the Griffin 1X. But I'm wondering if we have enough clearance for it. Or if we're going to have to put in an offset. So the Skipper would go there. We're definitely going to need to put in an offset. Okay. So let's go into our coupling here. We do have access to these radial decouplers, which is the kind we're going to switch to. So we'll quad couple these, and we'll place it right here. And right like that. And that gives us just barely enough clearance. I'm also going to move these up ever so slightly. There we go. What does that do to our aerodynamic? We're going to be very stable. Luckily, we can gimbal with this, so we'll be able to provide some level of thrust. Okay. So let's just double check our staging here. This is definitely incorrect staging. So we'll do something like that. Oh, this thrust to weight, so much better. 1.98 and then 2 once we're up top. So that'll be fine. This might in fact be too much thrust to weight. We'll see, but we definitely want to put this interstage back in. So let's go ahead and grab this off of here. And we are going to put in the T800 again, and we'll check our thrust to weight once we have that in. I think... Do we want to run the swivel here for the interstage? Just for the more thrust to weight? Yeah, I think we do. Just for additional thrust to weight on that. So we'll run a swivel there, and then a TD12, and then we will hook this in right like that. Okay, this decouples there. That is definitely wrong. So in this stage... We're going to need to check all this. So these 5 engines burn at once, and then these 4 side boosters all fall off, and this thing's going to burn through this fuel very quickly. We don't have access, unfortunately, to the bigger fuel tanks, do we? We do have access to some of the Rockamax fuel tanks. We have access to the Bobcat, but also the Poodle. You know, we should overhaul this. That gave us quite a lot of tech. So what I'm going to do is I'm actually going to completely overhaul this stage here, as well as this stage here. This is going to remain as is, but we are now going to need an adapter here. If we've got a Rockamax brand adapter, that would be ideal. Rockamax brand adapter. Fantastic. So we do that. And then we'll put in a Rockamax 32 worth, and I'll just go ahead and make that be orange. There we go. And the Rockamax 32 worth is going to be powering our Poodle. And what's the thrust to weight on that Poodle? 0.18. Fair enough. But theoretically, That's fine. Then we go ahead and do TD 18. No, that's still too small. 25? TD 25. Fantastic. And now we're going to need, unfortunately, we don't have access to the Rockamex 64 tanks, but we can emulate it like that. That would be a Jumbo 64, right? 16, 32, no, this would be a Jumbo 64. We'll make it orange because I like big orange tanks. Excellent. We'll put a skipper on there. What's this thrust to weight as is? We don't want to burn these at the same time. We're currently decoupling awkwardly. So we would need to move this decoupler into this stage. 0.77. So this does not have thrust to weight to lift. So we definitely need side stages. This does have some gimbaling, but we'll probably want to have some level... Yeah, that should be okay. We'll want to have some level of aerodynamics over here. Yeah, that looks decent. Something like that. So this thrust to weight is, of course, awkward because we want to have this decouple here and fire like that. So 1.19, that is not great. Okay, so we're going to ditch these and completely redo this utilizing the Rockamex. So we'll put we're just going to two-couple this, bi-couple this. So we'll do that, and then we will put in, say, another Jumbo 64 here. 1, 2, 3, 4, like that. Together with another pair of skippers, like that. Then we're going to need a big old aerodynamic nose cone, like this one. I'll make these be orange, because I like my big orange tanks. These are kind of small orange tanks, so... We're going to want to run our fuel lines in, like so. And then I'll put in some struts just to make sure. And this should be fine up here. So how are we doing on thrust to weight? 0.75. Oof. We're gonna have to cut the size of these, I think. Maybe something like this? Oh, wait. Undo that. Put that back. This was not in this stage. 1.12. Okay, so I think we still do need to ditch these tanks. And then these go back in, like this. They get combined together, 1.27. That's still definitely on the low side. We could cut this fuel in half, and that's probably okay. 1.36. I was hoping that the skippers would be able to lift enough here. I mean, I'm used to using mainsails, there's no doubt about that. This might be able to get there. And at this point, this is the Griffin 2X, not the Griffin 1X. So we'll save that. And of course, we're going to need to do something about this aerodynamic position. So we'll put some winglets over here, as well as over here. We will need more winglets than this. This is slightly ridiculous. Well, that's going to be very stable. It's still slightly ridiculous. We could use some solid rocket motors to try to boost this up, in theory. What is the skipper's ground versus vacuum efficiency? Very similar. Okay. Interesting. So, with this in mind, is this enough thrust to weight? But once we get here, our thrust to weight is 0.86. What if we don't flow fuel in? It's a little bit better, but we only get 39 seconds of extra burn out of this, doing it that way. And then the thrust to weight here. So yeah, I think we're going to have to bring this down. So we would have to scale this stage down to perhaps a T800 with a swivel, as we were thinking about doing before. And then we would run a TD12 decoupler here. And then a Rockamax brand adapter here into this stage, like this. And what's that DV, or rather that thrust to weight at? 0.93? Okay. And then we would have to probably quad couple onto here, like this. Some additional fuel tanks. Something along the lines of this. Although this looks disgusting. What is going on here? Why are these offset? You know what? We'll just make them orange. That fixes the problem. Fantastic. And then we would put on skippers down here. And realistically, all of these gimbal, right? So this might actually be okay. What's this thrust to weight? 1.32. This is not great thrust to weight, but honestly, it's going to burn for a sufficiently long time that might be okay. So then a protective rocket cone like that. We could potentially ditch these and then flow the fuel in. And I think we'll do an experimental launch of this. This is going to be basically a simulated launch. So I'm going to be free to revert this launch. This is not a real launch. This is just to see how our thrust to weight is looking. Okay, so we'll do this as kind of the finale for this episode, if such a thing exists for my episodes. I did not check the staging. I'm aware of this. We're mostly just looking at the thrust to weight, but the staging is going to be wrong. I'm only interested right now in this staging right here, like that. So let's see if this thing gets to orbit. If it does, great. If it does not, oh well. Well, that's not terrible. The question is, well, we have two questions, right? The thrust to weight, and does the fact that all 5 of these engines gimbal compensate for the fact that we have no aerodynamic control surfaces? And we're about to find out that question. That looks reasonable. We're definitely kind of naturally pitching over. Oh, it's recovering right now. Boy, this is going to be a long burn. Oh. Nope. 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 Okay. So that's a lesson learned. Now the other question is, if we don't do an aggressive gravity burn, do we have enough to get to orbit? So, we've recovered that mostly. Oh, no, we're going the other way now. Okay, so I'm going to go ahead and revert that, and we are going to put on the control surfaces to make sure that that doesn't happen. I was just interested to see if the aerodynamics would be overcome by those gimbals, and they definitely were not. So that's good to know. And we are definitely going to need to put a few of these bad boys on. Now, where does this put our aerodynamic center at? That's actually not super low. So we could then... No, I don't want to grab that. We could grab this and place it there. And then, in theory, we could place another round of these here. Here. And here. So that would work. Okay. So, I have almost complete confidence right now that this is going to get to orbit, and if it gets to orbit, it gets to the moon. So I'm going to go ahead and put a cut in here, and next episode, this thing is getting to the moon. I promise. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.